In this tutorial, we're looking at 2023 Paper 2 Question 1, and it's all about probability. In the first part of this question, we're introduced to a circle, and this circle is divided into 12 sectors. 5 of those sectors are marked as €6, 3 of the sectors are marked as €9, and 4 of the sectors are marked as €0. We're told that Fiona is going to play this game 3 times. We need to find the probability that she gets a 6 the first time, a 9 the second time, and a 6 the third time. This is a permutation where we know the order in which she's going to get the numbers, so it's relatively straightforward to deal with. If she spins it the first time, the chances she gets a 6 is 5 out of 12. The second time she spins it, the chances she gets a 9 is 3 out of 12. And if she spins it once more, the chances she gets a 6 is 5 out of 12. We want to get a 6 and a 9 and a 6, so that means we multiply. You put a multiply in between them. And if you plug that into your calculator, your final answer is 0.0434. In part B, we're told that Rowan plays this game as well. And we're asked to work out the probability that he gets a 9 for the 3rd time on his 8th trial. In other words, the 8th time that he plays this game, that should be he should get a 9 for the 3rd time. You should recognize that this is like what we studied in probability 9. This is a Bernoulli trial. If you go to page 33 in your maths tables, you can find this formula called the binomial distribution, and it's the one we use when we're dealing with Bernoulli trials. First of all, this is much more difficult than in part A. Part A was a permutation because the order mattered. We had to get 6 first, then 9, then 6. This time it's much more difficult because the order of the first 7 trials is irrelevant. So the first 7 times that Rowan plays this game, the order doesn't matter, so we're going to use a Bernoulli trial for that. The thing that definitely does matter is I know for a fact that on the 8th time that Rowan plays this game, we want him to get a 9. So that the 8th trial is not included in our Bernoulli trial because the 8th time he plays it, he has to get a 9. Whereas the first 7 times he plays it, all we want is that he gets 2 9s. In order for him to get the 3rd 9 on the 8th trial, well, that means that in the first 7 trials, he must have succeeded twice, or he must have got the 9 twice. So let's sub in here. N refers to the number of trials, and we're talking about the first 7 trials. Or refers to the number of successes. And in this scenario, we consider Rowan getting a 9, that's success. So the number of times we want him to get a 9 in the first 7 trials is 2. So it's going to be 7, choose 2. P refers to the probability of success, and as we explored in the first part of the question, the probability of getting a 9 is 3 out of 12. And then OR is the number of times we want that to happen, or OR is the number of successes. We want 9 to pop up twice in the first 7 trials. Q is the probability of failure. And if the probability of success is 3 out of 12, then the probability of failure is 9 out of 12. And N minus OR is 7 minus 2, which in this case is 5. So if you plug that into your calculator, that gives you the probability that Rowan gets 2 9s in his first 7 trials, in any order whatsoever. Like he could have gotten a 9 in the first 2, and then in the next 5 he got 6s, or the next 5 he got 0s. Or maybe he got a 9 and then 5 things that weren't 9, and then he got 9 for the last one. The point is, we don't know what order the 9s popped up in, but we don't care. We want this event to occur, and then on the 8th trial we want him to get a 9. So we want this to occur, and then we want him to roll it or to spin the spinner one more time, and we want him to get a 9 on that trial. And so that means we multiply him by the probability of getting a 9, which is 3 out of 12. So this is the chances that he gets 2 9s in the first 7 trials, and this is the chances that the 8th one then is another 9. In other words, that the 8th time he plays this game, it's the 3rd time that he's after getting a 9. And if you plug that into your calculator, your answer works out as 0.0779. In part C, we're told that Olga also plays this game. Olga is going to spin the spinner twice. And we need to work out the probability that she gets something less than 16. Now, the first thing you should consider here is, how is it possible for Olga to get more than 16? There's only one way that can occur. If she plays this game twice and she gets more than 16, well, that means she got a 9 both times. So the chances that she gets more than 16, the only way that's possible is she spins it the first time and she gets a 9. The probability of that is 3 out of 12. And then she spins it again and she gets a 9 again. So 3 out of 12 by 3 out of 12, that tells me the probability that Olga gets something greater than 16. And that is the only way she could possibly get something greater than 16. If she got a 9 and a 6, it's not big enough. If she got a 9 and a 0, it's not big enough. So any other combination is not relevant. The only thing that we don't want to happen is this. This event is the only thing we don't want to occur. What are the chances that anything else happens other than Olga gets a 9 followed by another 9? Well, to do this, we have to think in reverse. Remember that in probability, 1 represents 100%, or 1 represents everything that could possibly occur. So 1 represents all the combinations that Olga could get when she plays this game twice. And if I just subtract the only combination that we don't want to occur, well, that leaves us with all the other possibilities. So everything minus the chances that she gets a 9 followed by another 9. Well, if you plug that into your calculator, you get 0.9375. So the chances that Olga could get something less than 16, in other words, that she doesn't get a 9 followed by a 9, it's 93.75%.